Hello everyone, this is Samant and my project team member is P. Upendra from Department of Information and Technology, Vokaraju Rangaraju Institute of Engineering and Technology. Our project is fast and efficient indexing and retrieval of data based on Pareto principle on Euclidian dominant graph databases under the guidance of Ms. T. Anita, Assistant Professor, Department of IT. Our project proposes a fast and efficient method of retrieval data based on a popular management principle called Pareto principle, which considers filtering of data records based on a query function applied to Euclidean databases. This database is separated into various levels for efficient retrieval in this method. Existing system does not address the layering of data based on Pareto principle. They only uses Skyline's algorithm for addressing the database indexing problems for fast retrieval of it. This leads to increase in search space of data records, thereby providing inefficient in handling large number of records in database. This proposed system addresses the issue of efficient retrieval of data from a limited search space created on the basis of Pareto principle in a layered Euclidean database. Advantage: this approach results in fast retrieval of data records from a limited search space of Euclidean databases. We developed this project based on a journal on International Journal of Information Technology and Management Research from July to December 2013, given by Sri V. Satyanarayana and Sri K.P. Supriti, Department of Computer Science and Engineering, JNTU College of Engineering, Hyderabad. According to the journal, we developed four modules. They are basic traveler algorithm, inverse traveler algorithm, insertion and deletion. Basic traveler algorithm. Here we select the data set. It is here we have tables, different type of data sets, Pareto underscore data query, cup underscore data, income. We selected income, select k values. Here we have to enter the top k value, that is the layers value, and here we are entering the query function which we have to execute. Here we giving the priority directly to the columns by giving the numbering for the priority 0.2 and 0.2. After submitting the query, we can observe the process, and here we get the results, that is company ID, company name, turnover in crores. This is the real-time dataset of the Indian company, and here on the beside window we can also see the process. Next we are going to inverse traveler algorithm. This algorithm is developed to retrieve the n-dimensional data. Here also we are selecting the data set, it is income. This is n number of rows and columns are retrieved by this algorithm. And here we can set the n value, that is how many columns are there for a data set. We have to use it for this retrieving method. Here we are selecting 5, selecting 4, and here we are entering the k values, top k queries. Here we are entering the 6, so top 6 queries are executed. Entering the function, query function, here we are entering by giving the priority directly to the columns. 0.2 star p, that means the priority for the p column is 0.2, and the priority for the q column is 0.2, and the priority for the r is 0.4, and so on. Here the Priority of the R column is more than the priority of the P, Q, and S columns, that is 0.4. Based on the priority, the execution and query functioning process is done on n-dimensional data. Here entering the 4 columns names because it's a well, and after second here we can see the process on behind the window. Here also some company ID, company name, and the turnover in crores. And also we have a comparison chart, and this we are entering into insertion. And the insertion and deletion both come to the maintenance insertion. Here we have to select the data set from the database where we have to insert, where we have select the sample underscore data. The data set contains the 3 columns, so we are entering the record to it. We are entering the values for all 3 columns. Column 1 company name, column 2 and something value, and column 354. After clicking the insert button, the insertion sample data was successful, and we are going to the next algorithm, that is the deletion algorithm. We are going to change password. We are giving a initially we developed it as a system, so we give a username and password for the login. So we are entering here by using this. We are using, you can reset the password. We developed this apart from the journal, and we are going to deletion algorithm. So deletion algorithm, we are have to select the data set where we have to delete, and there is asking for the transaction ID for the in sample data set. Every row contains a transaction ID. Based on the transaction, the row will be deleted. So 106 is already deleted, so there is no any record named 106, so we have to give another name, that is 107. So 107 transaction ID named record is successfully deleted. So apart from the journal, we developed one more algorithm, that is index versus not index comparison. This is the apart from the journal developed by our new concept. Here this journal is mainly used for retrieving the data from the most frequently used datasets very fastly. We are entering a query, that is select count select star from L1. We will select in the list of executing a query, and we can see the number of records on the query and the time delay for this executing, time taken for the executing. We are entering the new query, another query. Select star from sample underscore data. We are entering the algorithm for the without the normal Bushman, where the number of records and the time delay is 0.113 seconds, and the same query is executed on a most frequently used datasets, so that the time delay is very less, 0.0030, because, and we also get a comparison chart. So the comparison chart time delay in seconds and the non-indexing datasets and the indexing data sets. So this main reason for implementing this module is we are it's take very less time to retrieve data from the frequently retrieve data from this algorithm. Thank you.